Okay, so good morning, and maybe we will get started here. It looks like people have found the poll, so that's good. There's some feedback here, but if you have anything else you would like to add, you're of course welcome to do so now while we're getting started. And let's have a quick look at the things that have been posted here so far, and then we'll continue on with today's lesson. And unfortunately, Kamyar can't join us today, so it'll be just me for the teaching today. So in terms of the comments that are here, I have to say I'm rather embarrassed that I completely don't get the bottom one because I've never seen any of the Lord of the Rings movies. So I don't know. I feel like I'm fairly culturally literate, but I have no clue what this refers to. But there are a few comments. Obviously, this exercise number 6 and week number 6 in the course is sort of in some respects as complicated as things get in terms of the data analysis that we're working with. And so it's pretty typical that this is a place in the course where students have a bit more uncertainty in terms of what they're doing. The comment here about the design of the third problem in exercise 6 perhaps being organized differently that would have made it easier to be able to sort of look at what you're doing and continue on with the work without having to scroll back and forth to the instructions. That's useful for us. So that's something that I think we could consider how we might be able to organize things a little bit differently, because it is true that a lot of the information is laid out at the beginning here, describing what to do. Initially with this problem, we had less information up here at the top. It was just kind of a shorter introduction, and then you were set free to do the parts of problem number 3. And so over time, this has become a little bit more detailed in terms of the instructions that are here, which perhaps is also then leading to this frustration that you have to kind of jump back and forth between the different parts and what you're supposed to be doing for the coding parts of the exercise. And yeah, that's a useful comment. So that's something that I will make note of, and we can see if we can organize things a little bit differently for next year. Completed the exercise without using a for loop. Should there be one? I don't necessarily think you need a for loop for the exercise. I think it's possible to do without. It's quite typical that you would use a for loop, for instance, to loop over the years of your data set when processing some of the data, but you don't necessarily need to do that. So if you were able to complete the exercise without a for loop and you feel like you've done everything more or less correctly, that's not a problem at all. In fact, it's probably faster in terms of the execution time for the code if you don't have a for loop in there. Generally speaking, loops and conditional statements do slow your code down a little bit. So if you can avoid them, because pandas is built on top of NumPy, which is designed to do these kind of array operations without using loops, of course, that's not necessarily a bad thing. However, I can't say for sure with any confidence for the comment that was made here whether or not the solution is right without actually looking at the code. But I think it's possible to do without a for loop, so that's not necessarily a problem. Hard time to understand how to do exercise 6. Still don't know. Yeah, I think if that's the case, if you still have questions, we can perhaps discuss during the break if you'd like some feedback, or you can also contact the course assistants, and we might be able to give you a little bit of extra time if you're stuck with something on exercise number 6 and don't know how to do it. I will say that's kind of a double-edged sword, because a little bit of extra time might help you finish exercise 6, but it also eats into the time for exercise number 7. So we'll have to proceed with a bit of caution. But if you have problems, maybe come see me during the break and we can talk about that. Wanted to know how we can define the index value for an x in the column y. I suppose this is a question about if you have two columns where you have data and you would like to use the values in Y as the index for your data set to be able to refer to the values in X. I think I don't have a ready-made example for this right off the top of my head for how to show you how to do it, but it is possible to set a column from your data frame to be the index, and if you do that, then you should be able to use that, whatever column it is, to reference values in another column in the data frame. So yeah. Yeah, I mean, it's not a method that we've introduced in the course, so, but yeah, there are these index methods like .idxmax and .idxmin you can use for locating maximum minimum value, finding the index of those values in a data frame or in a column of a data frame series. Maybe that covers that for now, and if there's other questions, we can discuss further. And then, do we still have a pair for the exercise this week? And when is the independent final project? So yeah, we'll come to that at the end of class today. But basically, you're still able to work with your partner this week if you'd like to for exercise number 7. That's fine and kind of keeping with the way things have gone for the other exercises. But for the final exercise, that is meant to be done independently. So we will discuss that when we get to the kind of exercise introduction part at the end of class today. But for that, you are, of course, able to still discuss things with your partner, but you're turning in your own exercise written in your own kind of words and with your own Python code. So that is a bit of a difference from the previous weeks, but at least from our kind of perspective as teachers, we feel like the final exercise is a bit like an examination, that it should be done by you so that we can assess kind of your level of understanding of the Python code. But it's not like you don't have to work completely in isolation. You can certainly talk to your partner and talk to other people in the course if you're stuck on something to kind of get some feedback about how to proceed. So I think that covers our questions and things so far from week number 6. Is there anything else anyone wants to ask about before we proceed into week number 7? All right, so let's have a look here at the course website. You should be able to see now exercise or lesson number 7 and the final exercise stuff is visible. We'll come to this at the end of class, as I've already mentioned. But our topic for today in the last week of the course is to get into data visualization a little bit, because what we've done to this point is we've learned some kind of basic Python things, starting from really kind of getting familiar with how to assign variables in Python, to working with Python lists. Then we got into for loops and conditional statements, functions, and have spent the last 2 weeks looking at things with pandas. And because we can now read in data files, and at the very beginning of the course, you might remember this kind of motivating example where we showed a table of data output, and it was not particularly engaging to look at. The topic for today is looking into visualizing that data as a more powerful way to deal with things that we can now process using the pandas library, for example. So we will talk about how to make some basic X, Y plots using pandas and Matplotlib. Matplotlib is a plotting library that we will talk about momentarily, but it's used kind of under the hood in pandas, just like NumPy is. And then we'll talk about how to modify your plots to manipulate different parts of them, and how to create plots in Jupyter Notebook and save them to image files so that you can use them in other settings, for instance, in Word documents or web pages or whatever. So that's where we're headed. And we can start in by our first bit of the lesson about plotting in Python, which links to this Introduction to Python for Geographic Data Analysis, book chapter 4.1, which looks like this. Make this a little bit bigger. And our starting point here in talking about doing data visualization in Python is getting a sense of the plotting landscape in Python. So it's diverse, and there's quite many different types of plotting libraries that you can use to visualize data in Python. And this first part of the lesson, we have here just kind of a picture of what things look like. And you'll see there are certain, I would say, like hubs where things branch from. So for instance, Matplotlib is here. Matplotlib is kind of the original, or one of the original plotting libraries in Python. And all of these things that stem from Matplotlib, such as pandas, is using Matplotlib. You may have heard of Seaborn if you've done anything with Python data visualization before, or Cartopy, which is a popular map visualization library built on top of Matplotlib. But these all draw from various parts of Matplotlib, or even use Matplotlib as a kind of foundation for the data visualization that they're doing. So they're kind of built on top of that. And with this graphic that's here, you can basically get a sense of what our options are as far as different libraries. And as you get a little bit more experience with plotting things in Python, you may want to install some of these packages yourself and explore how they work, because basically each one has its own reason for existing. Seaborn is designed for doing statistical data visualizations. Obviously, we're familiar already with pandas, but there are things like Bokeh over here that's built on top of JavaScript that's more designed for doing interactive data visualizations. So we will see an example of these kind of interactive plots later on in class today. There's some that are built on top of OpenGL for doing more 3D visualization and kind of 3D things that can be manipulated interactively. And there are these kind of, I don't know if you'd call it a meta package, or things like HoloViews that are bringing in pieces of things from Matplotlib, from Datashader, and from Bokeh to allow you to do a whole diverse different set of types of plots with a single plotting library. So this is the landscape, and what you'll see underneath here is a description of what these libraries can be used for, and in many cases, if not all of them, a link to a plot gallery so you can see what kind of things you can do when using the libraries. So Matplotlib is at the top because it is the kind of original plotting library that is still widely used. And if you, for instance, click on the Matplotlib library link, it opens up a page like this. And you can see examples of different styles of plots that you can create with Matplotlib. What's nice about this is not only can you take a look at these kind of plots and maybe find one that's close to something you would like to make, but when you click on one of the examples, it opens up the code that's used to produce the plot. So if you wanted to make these plots down here about using this fill between, which essentially will fill in the space between given reference value and the function you're plotting. So this is looks like a sine function where it's filled between the y equals 0 value and the function value. There's also the example that was shown in the Matplotlib library here, which you can basically just copy paste this code into a cell in the Jupyter notebook and reproduce the plot. If it's something you want to work with and it's close to what you ultimately want to do, this is a good place to get started, because obviously you can save yourself the time of trying to figure out how to do things like this. I mean, for me personally, the fill between idea I get, but I never remember how to do it. So it's much easier for me to go find an example where I can say, right, this is how I do this. And then I can do things like make plots where I have some kind of confidence interval around a line, for example, and then points that are shown there. So these galleries are quite handy, and you'll see there's, I would say, a pretty good number of different example types of plots. Because Matplotlib's been around for a long time, it can do a lot of different things. You can plot images. So if you want to make a picture of Grace Hopper, you can do that. But there's lots of different possibilities for plotting with Matplotlib, and great number of examples that can be useful for generating these kind of plots. So you'll see that there's Matplotlib, there's Matplotlib basemap, which was kind of on its way to being deprecated a couple years ago, and I guess caught the interest of some open source programmers and has now come back to life. It's basically a 2D map producing library for for Python using Matplotlib as its base. There's Seaborn, which I mentioned for doing statistical data visualizations. I think Seaborn is popular for that reason, but also because it makes nice looking plots. And if you look again at the library here, you can see its gallery, and you can find example plots of things that if you want to make some kind of nice looking heat maps, for example. This is something I do occasionally in Seaborn because it makes pretty looking plots. You can make these type of heat maps, and again, you can find an example of code to be able to do this as a way to get started. So I think that's pretty great that they do things that way. Even the default plot style in Seaborn, I think just looks nice visually. It looks much nicer than the default plotting style in Matplotlib. So this is kind of, I don't use Seaborn, but I use Seaborn style plots when I make things in Matplotlib because I think they look nice, and there's an easy way to do that, to make these sort of Seaborn style plots. As mentioned, there's Bokeh, which is used for more interactive plots. You can do static plots as well, but it's typically used for interactive things. And again, you can find examples by going to the Bokeh gallery. And here, just to show you, if you click on one of the plots, let's hope we got lucky and got an interactive one. We did. It opens up like this. You can scroll in and out to zoom. You can click to pan. And depending on how it's set up, you can often mouse over the values to see what the values are of the points that are plotted. In this case, it looks like this plot is not configured to do that, but some of the other examples would. And there's lots of different options for making these kind of interactive plots. What's cool is it's easy to take a plot like this from Bokeh, and if you make it in a Jupyter notebook and export the notebook as an HTML file, it also exports this as an interactive plot. So if you want to put it online, there's an easy way to get Bokeh plots to show up as interactive things on the web, which is kind of handy. Let's see if we can find one where you can mouse over the values and see. Nope. Maybe we're not going to have any luck with this. There we go. So there are things here where you can, as mentioned, mouse over them, and you can see other things from the data frame that's being used to plot this data. So for instance, this looks like, I don't know, it's plotting things in terms of density and atomic weight. And so if you put your mouse cursor over gold, you can see its density and its atomic weight, its melting point, which is information not shown on the plot here, but it's in the data frame. That's the source data for this plot. And there are some other examples where you can have little kind of slider bars and things where you can turn on and off different parts of the data set. In this case, I think there's no way to hide the data that's here, but anyway, you can play around and look in the Bokeh gallery if you're interested for those kind of things. So there are some others here. I'm not going to go through all of them because that would take our whole course time, and we have other things we need to cover, like actually how to make plots today. But I would encourage you to have a look. There's lots of links here that will allow you to check things out and learn more about the different plotting libraries in Python and how to use them. There's also information here about different styles of plots and charts that you may make with Python. This is mostly just for reference information, but it's pretty much all Wikipedia articles that are linked to describing these different kinds of plots. But in terms of the terminology, if there's a certain plot style that we have referenced in the course or that you've heard of, like a, I don't know, violin plot, for example, you can go here and check out the article on what a violin plot is, and then you know what term to search for if you're trying to make a plot that looks like this. I don't ever use these, so I don't actually know what violin plots are all about. But the information is there on the course or in the book, linked from the course page for many different styles of plots, and you can of course read more information through the links that are there. This is mostly just as a reference. But the one thing we should talk about is the kind of common elements of a plot, because we will refer to some of these things. These are labeled mainly using the Matplotlib terminology. So there's lots of different green boxes on here indicating the names of different parts of the plot. I think all of you are familiar with plotting data on XY plots, for example. It's not something that's completely new, but you might not know that, for instance, the text that's used here to label the ticks on the plot is called a tick label in Matplotlib. So if you're looking for how to change the font size or the font style for the tick label, it's helpful to know what to actually search for in this case. Or if you want to know how to move this text that labels an axis further away or closer to the axis, that's called padding in Matplotlib. And you can find plenty of examples online if you just start searching for this, but you need to know what term to search for. So we have XY plot here. You can see two different lines with some values shading between them. There's a legend, there's grid lines here in the background, a title. These are probably things you're already familiar with. It's sort of X and Y axes. If any of this is new to you, of course, there's more information here describing how things work on the plot. But we'll use some of these terms in today's lesson, so this is here as, again, a reference for you to make sure that you feel like you understand and can follow what we're discussing when we're introducing Matplotlib. And you can find a table down here that's describing these different terms in kind of as simple language as we could possibly come up with, because it's in a table, so it can't be lengthy in terms of the description that's here. I think alpha is maybe not shown on the plot. Guess not. That's maybe the one thing that's not labeled here, but alpha is what's used to describe transparency in plotting libraries in Python. So value between 0, which is fully transparent, meaning it wouldn't be visible on the plot, and 1, which means it's fully opaque or not transparent at all. And that's something, again, when you get into kind of styling your plots and you want to make things look nice, I will tell you, for instance, that having a full, like, alpha of 1 fill between two lines usually is kind of ugly. Like, it's a bit too intense. So you can see actually the grid lines behind here because this is partially transparent. So this is probably an alpha of 0.5 or something like that. So you can see through. It shades the area in between, but it's not like a bold, bright red color that would be perhaps, I don't know, visually unappealing. Maybe we could say it like that. So that's our kind of plotting landscape as far as Python goes, and this part of the lesson, again, is mainly there just as a reference point for you. So let's actually get into now what we're going to talk about today, which is our plotting in Python stuff. I'm going to close a couple of these tabs for the examples here. And if you haven't already, business as usual, you should launch your Noppe instance and head over to the My Work folder and the Notebooks directory, and you can go to the Git plugin and pull the latest changes. I've already done this, so I have them here, but if you haven't done that, that will give you the materials for today's lesson. This is lesson number 7, and we're going to start with this basic plotting notebook where we'll introduce how to make a plot with pandas and Matplotlib. And I will just hide the file browser so we can see as best as possible what we're doing here. So our first step, as you might imagine, is we're going to be plotting data using pandas, which means we need to read our data in. There is a file path that's defined here that actually references the shared directory where there is a data file. We haven't used the shared directory because we've been working with smaller data files this year, but the data file that we have in here is something like 130 megabytes. So it's a decent sized file that rather than having you all download this to get started, we put in the shared folder, which you should all have access to. And in this case, all we need to do is run this cell to read in the data file. But I want to highlight a couple things. First off, we're using this sep thing as to define our separator. Our data file has variable numbers of spaces between the columns in it. And there used to be a kind of parameter called delim whitespace in pandas. That's maybe, did we even introduce that earlier? Or yeah. If you use delim whitespace, you're going to get a warning message about it being deprecated and that it's something we should stop using. So this is the example of how to use what pandas recommends instead of delim whitespace. I think delim whitespace is a much more intuitive and clear thing to do than saying sep equals r quotation mark backslash s plus quotation mark whatever. This is using regular expressions to indicate there's a variable number of spaces between columns, and it's really clumsy looking, but it is a more flexible and consistent way of being able to handle complex separators between columns in your data file, and this is what it looks like. We haven't really talked much about raw strings in the course, but we have F strings, right? That should sound familiar, that we've been using. An R string or raw string is another type of string that here will use exactly these characters. Normally this backslash is used as an escape character in Python. It's kind of a special character to allow you to put like an asterisk into a text string and have it display properly. When doing this, it's best to use this format or else you'll get some syntax warnings if you don't put the R in front of this. So that'll read our data file in with these separators, but then we're also, while reading in the data file, going to use the index call parameter, which will allow us to say that we want to use a certain column as our index. In this case, it's the column that's year, mo, da, her, which is year, month, day, hour, and minute of the observations. This is basically our time column. And we're going to index our values by time. And we're also, while doing that, going to use the parse dates parameter, which will read in the text in that column, which is written as a long character string, and convert it to a date as a datetime object in pandas. So we saw that, I think, already earlier in both, maybe in week 5 already, we kind of mentioned date time, and then last week you would have seen there was some optional material about date times. So if you run this, what it's going to do is read in our data file, and for the index, instead of starting at 0, 1, 2, 3, etc., you're going to see that our index value is actually the date of the observation, which is handy, especially for making plots, because it makes nicer looking labels for the plots when doing this. So I read in the data file, and now we can take a quick look at this by just doing data.head, see what we have in our data that's been read in. So data.head, what you can see now is our column here. In the first column, the index is a datetime object. So you can see here we have our first observation from the year 1952 on the 1st of January at midnight. And then we have year 1952, 1st of January at 6 in the morning, midday, and 6 in the evening. So 4 observations per day. And obviously we've got some missing data here as well. So as you might imagine, our data set from the 1950s is not complete in all instances. We have a temp, which is the kind of average temperature for the day, but the max column is clearly missing values, and the min column is clearly missing values. This may depend a little bit on what we are working with. But yeah, question. Yeah, I mean, if we just did like this, for the sake of keeping things reasonable, what will happen is we basically get the head, some ellipsis here, and then the output from tail. So it shows you kind of starting and ending things. In this case, we have 930,000 lines of data. So if it showed the whole thing, obviously it's going to be slow to put it onto the screen, but also probably a kind of nuisance to navigate around. I think what's happening here is a Jupyter feature that it's kind of truncating things. But actually, I'm not entirely sure. This could be dangerous. But yeah, actually, when you print it as well, it does get truncated. So it may actually be something that Pandas is doing. I'm not, we would have to drop into a terminal and load this into like a Python script to see for sure, but it may actually be pandas that's truncating this, because now that I think about it, there is a variable you can define in pandas to define how many rows you want to see when you do things like printing it out to the screen like this. So we had some places in the book when we were working on it that we wanted to have more lines visible for some of the examples. So sometimes you want to see like a whole year. If you have like monthly values, you might want to see 12 rows by default, whereas pandas would show you 5. So you can tweak some of those things if you go digging into the fine tuning of how pandas output works. But yeah, there was another hand.
I was just going to say that I've experienced this before, and like Python just stops at it. Like it says that there's too many rows that we get rid of.
Yeah, okay. Okay, yeah. Yeah, I think it kind of depends a little bit on the library. I think in this case, pandas is handling the output, so it's doing its thing. And I think it's, yeah, maybe I misspoke earlier when saying it was a Jupyter thing, because I think it is pandas actually that's controlling this output. But I mean, the kind of typical way in which you would, deal with it would be just to do data.head, and if you wanted to get more rows. The fastest thing, if you wanted to see, like if you have monthly observations, you want to see a full year, it's easiest thing to do is just do data.head and then 12, so you see 12 values, rather than going in and, like, at least for me, I would have to go look up, okay, how do I change this setting in pandas to show more or less rows, and I'll waste a lot of time. So I think, yeah. I think it will, at some point, yeah, so even if you try and do like 120 rows, it starts saying, this is too much output. So pandas catches it and wants to say, I'm not going to show 120 rows without adjusting one of the default settings. So we have our data set here. We have our temperature values, their max and min. And in some cases, I think the max value, it may be missing for some parts of the day, perhaps because maybe it gets the max value from looking at all the observations earlier in the day and records it there. We would have to look at more of the data to see how this pattern goes. But it looks to me like there's some regularity that at 6 o'clock in the morning, it always seems to have the minimum value recorded. And at the midnight of the end of the day or start of the next day, it always seems to have the max value recorded. So maybe there's something there, but you'll see that varies. If we looked, for instance, at tail, we now have NaN values for both columns for the day. So we've got a variable thing going on with our data in terms of how it's formatted here. But we're not into the sort of let's fix our data set stage right now. We learned how to do that earlier. If we wanted to clean things, we of course could drop some of the rows where there's missing data. What we're interested in doing is plotting our data, and we can start our first plot by saying AX equals, and then we'll say data.plot, and that's it. So if we want to plot something using pandas, we can simply do data.plot. And when you run this, it takes a moment. As you could imagine, there's 930,000 lines of data. It takes a second to make a plot showing those values. But what we can see here is we have now this kind of wiggly looking thing starting at the year 1950. Okay, 1952 is when we know our data set starts. There's a gap. It looks like maybe from the sort of, 1962 or 1963 up until maybe the mid-70s. And then we've got our wiggles back after that. And these are our temperature values shown in blue. What's much more patchy are the values of max, for example. So whenever there's not a number value in a Python plot, it will, if it's supposed to be a line, break the line and skip to then the next segment. So it's only drawing things that are kind of connected between different segments of where we have our max values or our min values. The min values are kind of hard to see. They're in green, but they are here. Well, we've got a plot. It's maybe not the most beautiful plot, but we have a plot, and it's just as easy as doing data.plot with pandas to get a first look at what our data set looks like. Now, let's just take a quick look here. You might notice that when we did data.plot, we assigned this to a variable called AX. This is a kind of typical thing to do with plotting using Matplotlib or pandas, which is to assign the output of the plot to a variable where we could then use that variable to manipulate things in the plot later. So if we check out the type of AX, this is short for axis or axes. And you can see that this is in fact a Matplotlib axes object. So if you were wondering whether or not pandas is using Matplotlib, well, here's your proof. And this would allow us essentially to do Matplotlib formatting things to this pandas plot by playing around with this, as we'll see in just a moment. But yeah, very typical when you produce a plot, you don't have to, this will work without assigning it to the variable AX. But if you want to do something like this, like make the plot and then change the axis labels, it's far easier to assign the output to a variable because you can then use that variable to make modifications to things like the axis labels or other features on the plot. No, I think if you try to print it, I'll just do it here for the sake of simplicity. It just tells you the information about the axis object. So displaying the plot with Matplotlib is usually using this plt.show command, but it also probably won't work here because what happens when you do plt.show is it kind of clears the buffer of information about the plot and shows it the first time. So that's actually happening already here when we do our data.plot. This kind of plt.show I think won't display the plot because data.plot is already handling that kind of clearing of the buffer thing. So yeah, we don't get any output here. It's just kind of an empty thing. But you don't need to do it in Jupyter Notebooks anyway. Most of the time when you produce a plot with Matplotlib or pandas, it will automatically display it at the end of the code cell. If you do this in a Python script file, you do have to include this plt.show command in order to get the plot to be displayed. Because in script files, oftentimes you are producing a plot, but then you're maybe writing it to an image file or something like that. So the script files require this plt.show thing to actually tell it to display this on the screen. But yeah, printing AX just tells you the kind of information about the axis variable, which is kind of, in most cases, not particularly enlightening. Okay, so now let's take another example here. We had this huge data set of 930,000 lines plus stuff. Let's look at 1 day of data instead, which what we'll do is we'll take the last day in our data set, which I think sometime October 1st, 2019, in the case that we have here. So we can define a variable called oct1temps. We'll take only the values from the temp column and only for the last day in our data set, which as mentioned is 1st of October. So we'll say data, the column we want is temp, and then we will use our .loc accessor to give us the values where our index, so data.index, is greater than or equal to, and then we give a character string here for this date format, so 2019, then 10/01, and then we'll put it for the second, we'll just do the afternoon of October 1st. So here we have our year, and then we have our month as October, so month 10. Day is the 1st of October. I can't select the text very nicely, so it's there. And then we're taking only the afternoon, so we want the times where the time is 12 p.m. or later. If you run this, you can then do AX equals oct1temps .plot. So what we're doing is we're just pulling out a series from our data set and storing that as a separate variable and then plotting it same way that we just did. This will render more quickly because we're plotting far less data, but allows us to see a little bit more information about what's going on in our data set for this afternoon of October 1st. Temperatures here are given in Fahrenheit. That's probably not clear, but I would imagine that if you are aware, I think our data set is from, is it Helsinki Malmi Airport? I don't remember. Doesn't really matter, but I don't think we get temperatures of 36 degrees or higher almost any time of year here. So this would be quite exceptional already. And obviously in October, it's not going to be 40 plus degrees in Celsius. So these are in fact Fahrenheit temperatures. And in Celsius, we're kind of just maybe 5 degrees, 6 degrees above freezing, and temperatures going down close to freezing later in the day. So these are our temperatures, and what we've done is we've used the .loc accessor, as we've seen before, with this to allow us to select our dates. Because our data is indexed by the date, we can use this format where we can set here a conditional statement that says if the date is greater than this string, pandas will convert this string to a date and then do the comparison to allow us to see that we only get the afternoon of October 1st in our selection. Okay, so that's our plot for one day. Let's see if we can make our plot look a little bit nicer by adding some different features to our plot. So we'll start as we normally do. AX equals oct1 temps dot plot. But I'm going to add some stuff in here. I'm leaving this sort of set of parentheses open so we can define some characteristics about how we want our plot to look. And we can start with a style. So we are going to use the shorthand notation in Matplotlib to define the style. There's several different ways you can do things like define the type of line, whether it's a dashed line or solid line, its thickness, color, things like that. But Matplotlib has this shorthand notation you can use for defining these characteristics at once. So we can say, for instance, K here is the first thing to indicate that we want to use black line. I know K doesn't necessarily scream black to you, but the letter B is used for blue in Matplotlib. And if you're using a single letter to represent things, you can only use it once. So K is used for black. O is going to tell us that we want to plot circles for our data points. And then 2 dashes will say that we want to use a dashed line. There's a link on the course page here somewhere, or on the book page, to this shorthand notation, so you can look up how this works. But this will allow us to define a black line with circles for the points and dashes between those points in the line. We can also define a title. Okay, this is more intuitive. So we could say, for instance, okay, so this is Helsinki Vantaa Airport. Whatever. You can put whatever you like there. But that'll be the title. It'll show up at the top of the plot. We can also define X labels. So the label on the X-axis. And our X-axis in this case is going to be date. So we can simply say date. And then our Y label will be temperature. And if you want, you could make this be degrees Fahrenheit. If you want to indicate that it is temperature in Fahrenheit, which is a nice thing to do. And then we can close our parentheses like this. So I just have split these different parameters out into separate lines because this is going to get to be a rather long line if we list them all, but it's your normal kind of thing. You've got a function and you've got parameters that you're defining inside there, and you're separating those values with commas. This is a bit easier to read like this because we have things like Helsinki Vantaa Airport temperatures, which if we put this all in one line would be kind of clumsy. But if you run this, what you'll see now is the same data that we had before, but obviously a bit more information. So now we know where we are, which I didn't know earlier. We know that our temperatures are what's on the vertical axis and that they're in degrees Fahrenheit. And we have our date now labeled here. So you can see, for instance, 10/01 for October 1st at 12, 2 p.m., 4 p.m., 6 p.m., 8, 10, and then midnight. So that's handy. Allows us to define quite a few variables for making our plot without having to do anything with Matplotlib yet. This is still basically just the pandas plot command with these values that are used to define our plot parameters. We can do a bit more, and there's some examples of things that are shown down here beneath this in the notebook we're working with. Like if we want to change the size of the plot, the size of the figure, we can do that with the fig size parameter. Fig size is a kind of funny one for most of the world because it is defining the size of the figure in inches. So this would be, I think, the width and height of the figure, so 12 inches wide, 6 inches high, which is perhaps unfamiliar units, but whatever, 30 centimeters and 15 centimeters, if that helps, or if you want to work in whatever millimeters, you can convert that accordingly. But you can define the figure size here, which, depending on the data you're plotting, you maybe want to change the aspect ratio. The default, I think, is something kind of like a 4:3 aspect ratio, or maybe a bit bigger than that. But if you have data where there's much less variation on one direction or the other in the axes, you may want to change that using the fig size parameter. So that's nice to do. You can also add text annotation on the figure. So we will do this in just a moment, but we could, for instance, go to a position X and Y on the figure and add some text, for instance, indicating that this is the warmest time of day or something like that. We can change the range of the axes. So if we wanted to have temperatures that go only from 3 o'clock in the afternoon till midnight, we can do that by setting the X lim. So this is the X axis limits to be between, this is obviously a date represented as a character string, but you can see the 1500 for 3 p.m. Okay, I guess this is 10 p.m., not the end of the day. But we could change our range of values we're plotting on the x-axis that way, and same thing for the y-axis. It's just a Python list with 2 values in it for the minimum and maximum. So this would have our minimum temperature of 38, maximum of 44. And we can do the same thing using date times, as is shown on the example here in the notebook as well. And we can add a legend. So we don't need a legend because we only have a single variable we're plotting here. It's kind of like, this is a bit redundant. But when you have more than one value on your plot, obviously you want to have a legend, or if you want to kind of make it clear what the symbols are. If it's not clear otherwise, you can add a legend very easily. And you do that by adding this label parameter when you make the plot, and then adding this ax.legend beneath where the plot is defined to be able to display the legend. So this label will add a thing that says, okay, this line can be identified in a legend, but you actually have to say ax.legend to get the legend to be displayed. So we have our modified example, and let's copy paste some stuff. So we have x limit and y limit we can use to define the axes. While we did that up here, it looks like it's suggesting we do this using the style from the date time example. So we'll just copy that and paste it here. And then we have our example of doing the same thing. So this is x min, x max. We could say y min is, what did we say it was before? 38. It was up here someplace. Yeah, 38 and 44. So we could say that our y min is 38, y max is 44. So we have xlim, and while our limit values are defined here, we'll use the xlim and ylim when we make the plot to display those. But we could say, for instance, now ax equals oct1 temps dot plot. We'll open up the parentheses here. And actually, let's just be smart about this. I'm going to scroll back up here to our last plot, because we're going to basically make this plot with some extra stuff on it. I'm just going to copy this output from where we made our nice looking plot above and scroll down and paste that where I just typed this in the create plot. So we'll start from that, because we know we still want to use the same line style. We want to have the same title and X labels, etc. And we'll start adding stuff here. So we could say, for instance, that our xlim is a Python list that goes from xmin to xmax, because we define those date time values up here as from 3 p.m. to 10 p.m. Same thing, ylim equals, and then we'll make another Python list from ymin, to ymax. So that's setting our access range as we have defined the values above. Now we're just putting them into the plot to say here's the range of values to display. We can add a label, so we can put this in a legend to say, let's say observed temperature, or whatever. And we'll make the figure a bit bigger by using fig size equals, and this expects a tuple, so it should be regular parentheses, 12, 6. So 12 inches wide, 6 inches high. I think the default is maybe 8 and 6 or something like that, but I'd have to go look in the documentation to be sure. But this should make our plot, our modified Python plot. But we're going to add some text on here, which we can also do. We can define where we want to add the text in terms of x and y values. So it will use whatever the x value would be the date, the y value would be the temperature, and it will display the text so that the lower left corner of where the text is placed is at the point we define. So if we said 2019, October 1st, and then the time of day we want is maybe 6 p.m., 1800. So again, 2019, 10:01, and then 1800. And the y value we want is, let's say 42 degrees, because that should show up in our plot. As you'll see, I've tested this out before, so it will work. And now we're going to use ax.text to display our text on the plot. So this is the reason, a good example of why we define this variable ax, is because now we can make reference to the axes where this plot information is displayed to add the text we want at position x, y, which we just defined above. And the text we can say is whatever, this is my text. Kind of a lame example, but it is what it is. And then finally, because we want to show the legend, we can include the ax.legend here. So a bit of stuff to type in, obviously, in this cell, but it's mostly just copied and pasted from above, so nothing particularly surprising there. And when you run this, if all goes well, what you should see is now we have a wider plot than we had before. That's because we did define this fig size thing. We can see this is my text displayed here on the plot. We have our legend displayed showing our observed temperature. By default, it will stick it up in the right corner of the plot if possible, but if there's plot things that are in the way up here, like if our points or lines go up into this corner, Matplotlib will look around and say, where's the best place I can put this legend that won't overlap with the data that's being plotted? Sometimes there's no possibility to position the axis or the legend nicely. But yeah, you can see now, I think, a bit of a picture of how to modify various elements of the plotting. And a lot of the stuff that we have done now is pretty typical things that you would do yourself when making plots. And it's not that bad. It's some stuff when you get into the nitty-gritty details with pandas and you want to start tinkering with certain kinds of things, or Matplotlib, they can become a bit of a hassle, but this kind of stuff, choosing the range of values on the x and y axes, the style of the plot, etc., is fairly straightforward to do, and you hopefully will pick this up if you do a bit of plotting with pandas or Matplotlib in the future. So let's cover a couple other things, and then we're coming up to our break here in the not too distant future. But let's talk about these date time axes, because this is something that's different than what we've done before. We have parsed our dates earlier. For instance, when you were doing grouping last week, you had to parse your dates to get the year and month to be able to sort of group things by year and month together, or in the exercise, I think you did a similar thing. But we have used this date time axis in part because it does things like recognize that this is a date on the axis here and nicely space the values out in a way that makes sense. If you have data, and let's say you had data for the 31st of October and the 1st of November with some year, you're going to have this long character string that's interpreted as the value that goes on the x-axis. If you don't treat this as a date thing, you'll get a big gap between days in the months, because you'll go from, like, let's say 2024 10/31 to 2024 11/01, and there will be kind of this unusual spacing in terms of the values. When you know, okay, it's only one day different, it should be spaced just like the difference between the 30th of October and the 31st. But if you don't convert this to a date, it reads it as a number, and then it will say, okay, October 30th and 31st were one day apart, and then there's this big gap to get to November 1st. So that is the reason why this is converted to a date here, because maybe you were wondering, like, why would we bother with this date time thing? It seems like a hassle. There is a good reason for it, and that's why we're going to dive into this in just a little bit of more detail here for the moment. So first off, when we're dealing with these kind of strings, like if we take this one here, 1 o'clock in the afternoon on the 1st of October 2019. We can convert that character string to a datetime object using the pd2datetime function, and we just paste in there the character string we have. So 2019 10/01 1300, just copied and pasted it from here. And when you run this, you can see it gets represented as this timestamp. Here's the year, month, and day. Now it's broken out into a little bit more readable format, and obviously the time of day is also more readable because it's been converted to this datetime object, which is designed to display date type information. So using this, we are able to do things like modify where on our plots we want to put certain kinds of information. The datetime issue, with positioning the text, is we have this kind of funny way that we've positioned the text here that is perhaps a little bit clumsy to work with, and in order to define the values that are displayed on the plot nicely, we need to sometimes convert things to a datetime object. So let's make another plot example here where we limit our time range from noon until 3 o'clock in the afternoon on October 1st. Look at temperatures between 40 and 46 Fahrenheit, and add a note on here showing what time of day was the coldest part of the day. So our start time in this case, we'll do pd2datetime. And actually, before I fill anything in here, I'm just going to, well, maybe I will fill this in and then I'll copy the line, because we're going to have the same, pretty close to the same line in all of these places. So 2019 for the year, 10 for the month, 01 for the day, and we want to have temperature or times between 12 o'clock and 3 o'clock, so 12:00 here will give us 12 noon. That's our start time. I'm just going to copy it and paste that down here and make one change, and that is to change the 2 here to a 5 for the 3 o'clock in the afternoon as our end time. And then I will paste here the cold time of day, which, as it turns out, is going to be displayed at 12:05. That was the cold time of this day. It's actually 12 o'clock. That's the cold time, but we're going to make it 12:05 just to move the text a little bit away from where the plot is, because otherwise the text will plot on top of the dot that displays the recorded temperature. I know this time in advance because I've done this example before, so we could also plot it, figure out what the cold time is, and go back and do this kind of iteratively. But then we have that, and let's go back up here. You can do it a few different ways. Yeah, I think it's possible to adjust the padding for where the text is displayed as well. I'm sometimes just lazy, and I find the easiest thing for me is just to add like 5 minutes or 10 minutes to the plot and just shift the text that way. But yeah, there's a few different ways you can do it. Let's grab our example plot from above. So let's just take this whole cell of stuff. And we'll just copy that and paste it down here to where we have our text about adjusting the axis limits. I'm just going to paste what we had before. I'll delete some stuff that I just copied because we don't need to read the datetime library again, and we don't need to define the xmin and ymin values because we just set the start time and end time up here, but our plot otherwise is pretty similar. So same style, same label, same title, etc. Our x limit will go from start time to end time. That's just like that. And we set our temperatures, what was it, from 40 to 46. So we'll just say our ylim is 40.0. Our ymax is 46.0. If we had to do some more involved calculation to get these limits, we maybe could define a variable, but these are just two numbers. It's easy enough to put them in as a y limit like this. Same label for the line when we plot it, same figure size. But now we want to add the text to the plot, which let's go ahead and I'll just change where this happens. So our ax.text, let's delete this stuff and just do it this way. The x position we said is going to be cold time. I think that's what we called it, right? Cold time. The y position is going to be 42 degrees, which again happens to be the cold time here. And then we'll add our text that says, like we'll make a little nice arrow thing, coldest time of day, or coldest time of afternoon, something like that. And then we'll leave our legend on, delete this because we don't need it. So we defined our time stuff here. We defined our limits here, and now we've added the text for the coldest time of day. So when you run this, what you can see now is the little arrow thing pointing. I think we could get fancy and put in even nicer characters and things like that for like a proper arrow, but sometimes, like for the sake of an example like this, this is the simplest thing. And if we wanted to, with Matplotlib, it's also possible to add annotation where you have sort of a line connecting a point on the plot to text that you want to display. Depending on what you want to do, you can make your formatting a bit more sophisticated, but this example is obviously just meant to kind of quickly show another case of how to use these date times to define points where you want to, for instance, define your axis limits and where you want to display text on your plot. So this brings us here to a question for you, which I think we can take our break and do this question at the same time. So let me walk you through what the question's about. So we want to create a line plot similar to the examples above with the following modifications. So 1, temperature data should go from 6 p.m. to midnight on the 1st of October. We want to use a red dotted line to connect the observations, and don't use any symbol to indicate the points. And we want to have a title that reads Evening Temperatures at Helsinki-Vantaa Airport on October 1st, 2019, and text label indicating the warmest temperature in the evening. So we're modifying a little bit our example above, and we'll be changing things like the plot style, which maybe it's useful to scroll back up here, because I think somewhere earlier in the lesson there was a link to the plot styling stuff from Matplotlib. Is that true? I guess I thought there was a link in here for this. Maybe the link didn't work. Well, we could do, for instance, this help oct oct1temps.plot to give us some formatting information. So let's go down to where our question is. It's here. I'm just going to add a cell. And if you help oct1temps.plot, you get information about the things you can do for the plotting. We haven't gotten into changing the kind of plot. We'll do that momentarily, or I guess after the break, properly speaking. But I think someplace in here, do we have something about the style? I thought this was in here somewhere. There's a lot of output from the help about the plotting functions. All right. Not seeing it. Maybe it's in here somewhere, but maybe an easier thing to do would just look for Matplotlib style shorthand. We don't want style sheets. Is it marker reference? Well, why don't we do it like this? You guys can get started working on the problem. I will find the web page where there's the example of the shorthand notation for the formatting of the Matplotlib plots and put that up on the screen. And we can come back then. Let's give ourselves 12 minutes because it's going to take me a moment to find this thing that you'll need to complete the answer to the question. And we can come back at 10:40. So I'll dig that up. You can work on the problem, and we'll continue at 10:40.